Just like you can follow a recipe in order to make the perfect dish, you can follow the recipe to to learn to be able to name and write a formula for ionic compounds. The recipe is very simple. You just have to pay attention to the rules. First of all, you need to know what an ionic compound is. So we learned in class that an ionic compound consists of a metal cation and a nonmetal anion. Remember, an ion is just a charged particle, so a cation, remember the cat, is a positively charged particle, and an anion is a negative ion. And they're held together by what's called electrostatic attraction. That means opposites attract. And because you have a positive and negative, they're held together to create an ionic compound. Now, you need to know the rules for writing ionic formulas and then the rules for naming ionic compounds. First, when you are writing formulas, ionic formulas, there are a few rules to follow. One, write the symbol of the metal first. Write the symbol of the metal cation first. Write the symbol of the nonmetal anion second. Metals always come first, always come first, always come first. Nonmetal anions are always second. Second, compounds. You'll never see a compound with a charge. Compounds are always neutral or never charged, are always neutral. That means that the net charge on a compound is 0. The net charge equals 0. So you need to balance the charges so that the charges then equal 0. There are two ways to do that. One is just to balance the charges. The second is to actually use a new method called the crisscross method, which I'll show you in a minute. Finally, you need to make sure that the ratio of cations to anions is in lowest terms. Cations to anions is expressed in lowest terms. Let's do an example. Okay? So, we are going to pick a metal and a nonmetal from the periodic table. We're going to pick potassium and chlorine. Okay, the first thing we do is we write the symbol for the metal. Second thing we do is we write the symbol for the nonmetal. Then we have to figure out what the charge is. In group 1, if you look, potassium's in group 1. So if you look at the upper right-hand corner, you see that when potassium forms an ion, it forms a +1 ion. You can also know that because potassium has 1 valence electron, so it loses that valence electron to be a positive charge. So it loses the valence electron, so it gets a +1 charge. Chlorine, meanwhile, wants to gain a valence electron. Because it wants to gain a valence electron, when it forms an ion, it's going to have a -1 charge. Now, remember I told you there are two different ways that you can balance the charges. The first way is you can just look. You can say there's plus 1 and minus 1. Well, if we have 1 times plus 1 gives us plus 1, and if we have 1 chlorine ion, 1 times minus 1 gives us minus 1. Plus 1 minus 1 equals 0. And you can see that then our formula would be one potassium and 1 chlorine. So we can write the formula KCl. The other way you can do it is called the crisscross method. In the crisscross method, what you do is you do exactly the same thing. You write the ions. Then what you do is you cross out the charges and you crisscross the numbers. So this one comes down here and this one comes down here. So essentially what you have is K1Cl1, and subscripts of 1 don't get written in a formula, so we have KCl. Okay? And then you check to make sure that your ratio is in lowest terms. 1 to 1 is lowest terms, so you're correct. Here's the next one. Try to write the formula for calcium and chlorine. Turn off the tape and give yourself a chance to do it. Then turn back on the tape and we'll do it together. Okay? Now, first we write the symbol for the metal cation, then we write the symbol for the nonmetal anion. We know that calcium is in group 2, so it wants to lose 2 valence electrons. When it loses 2 valence electrons, it has a charge of plus 2. Chlorine, again, is group 17. It has 7 valence electrons. It wants to gain 1 valence electron. When it gains 1 valence electron, it has a charge of minus 1. Now, the charges, if we had 1 calcium and 1 chlorine, wouldn't balance out. We would have a plus 2 minus 1. We would have a net charge on the compound of plus 1. So what do? Well, we have to figure out what number, what is the greatest common factor, least common multiple, of plus 1, of 2, and 1. And we realize that if we have 1 calcium and we have a plus 2 charge, we can easily make the chlorine a minus 2 charge if we have 2 of them, because 2 times minus 1 is negative 2. That equals, so then if we have 2 chlorines and 1 calcium, we have plus 2 minus 2 equals 0. So our formula would be Ca1, Cl2. Using the crisscross method, we can see this very easily. We have Ca plus 2, Cl minus 1. Okay, you cross out the charges, crisscross the numbers, and you'll see that this 1 comes down here, you get Ca1, and this 2 comes down here, you have CaCl2. So that would be your formula. Notice that the formulas agree. Okay, next, we got to learn to name these compounds. So our first compound that we wrote the formula for was KCl. When we're naming, we have 2 rules for naming. And these rules apply only to binary compounds. Binary means that there are only 2 elements involved. 2 ions, 2 elements or 2 ions involved. Okay? So what we do is we always name the metal cation first. Always. The metal comes first. Always the metal comes first. The metal comes first. Then the nonmetal is written second. But the nonmetal gets married. When the nonmetal gets married, she changes her name. so that she has an IDE ending. So let's see how this applies to our example. The first thing we do is we write the name of the cation. The metal cation is potassium. And then we write the name of the nonmetal anion. That's chlorine. However, because it's a binary compound, you have two elements, just potassium, or two ions, potassium and chlorine. The chlorine has to change her name, so that's potassium chloride. See, she got married, she changed her name, she now has an IDE ending. Okay, now you try the second one. How would we name CaCl2? Turn off the tape and try it yourself. Okay, the first thing we do is we name the metal cation first, is calcium. Then we name the nonmetal anion. Now we have to be careful. What we want to do now is we just name the anion, but we have to change her name because she got married to an IDE ending. Notice we only changed the name of the metal anion. Sorry, of the nonmetal anion. Be careful. You only change the name of the nonmetal anion. Try to complete the chart. Turn off the tape again and do it yourself. So if you have lithium oxide, okay, we look up on the periodic table. Lithium has a +1 charge. Oxygen has a -2 charge. What we do now, we have to balance the charges. The easiest way is the crisscross method. Cross out the positive and the negative, and crisscross the numbers. So you would get Li2O. Cross out the charges, crisscross the numbers. How about potassium nitride? Okay, first thing we do, we write down the name, the symbol for the metal cation and the nonmetal anion. We know that potassium's in group 1, so it has a +1 charge. Nitrogen is in group 15. In group 15, they have 5 valence electrons. Because it has 5 valence electrons, it wants to gain 3 electrons, which gives it a -3 charge. So to write the formula now, we cross out the charges and crisscross the numbers. We get K3N. Okay, now the next one we have aluminum, sorry, Al2O3. They ask us to name it. We have to name the cation first, is aluminum. And then we name the nonmetal anion. Only we have to change her name because she got married. Aluminum instead of oxygen, we change the name to oxide, IDE ending. NaCl would be the same deal. First name the metal cation, sodium. Then name the nonmetal anion, but change the ending to IDE. She got married, isn't she cute? Now, last one. They give you magnesium oxide. Magnesium oxide now. We have to write the symbol for magnesium is Mg. Magnesium has a +2 charge because it's in group 2. Oxide is for oxygen, is in group 16. It has 6 valence electrons. So if it has 6 valence electrons, it wants to gain 2 electrons. It has a -2 charge. Now, how do you write this formula? Cross out the charges and crisscross the numbers. You get Mg2O2. Does anybody see a problem with that? Hopefully you realize that the ratio 2 to 2 is not in lowest terms. So you have to change the ratio so that it is in lowest terms. What number goes both into 2 and 2 is 2. 2 divided by 2 is 1, and 2 divided by 2 is 1. So the lowest, the ratio in lowest terms would just be MG101 or MGO. Okay, so finally, test yourself. Use your periodic table to write a formula for an ionic compound, and then name that compound. Bring your notes to school tomorrow, and we'll practice.